Okay, in this final lecture I will show you some number of problems that you have to know how to solve based on the combinatorial methods, and I want to see a vivid approach to solutions. So that's why I want to apply different ways, but the main idea is the fundamental counting principle, multiplication rule. But you have to understand, you have to apply logic here, otherwise it will not work. Okay, so I will, how many problems? I just get 14 problems, and they will cover the whole sections of chapter 10. Okay, problem number 1. All the problems are formulated in the same way. In how many ways can be done this or that task, or how many numbers with this property are there. That's why I will not write the question all the time. I just will tell you the condition, and then the question is what is the number of ways to fulfill, to make this task. Okay, so we have number of 3-digit integers, ABC, so the digits are ABC, I call bar, such that A is not equal to 5, 6, 7, and B equals 5, 6, 7. Or so 5, 6, or 7, and C is not 0 and not 2. So A can be any number. Okay, so let's write A, B, C. So this is A, B, C. Any number, so any digit but 5, 6, 7. B must be only 5 or 6 or 7, that's it. And C is not 0, not 2. Okay, what is the reasoning? First of all, because we are talking about integers, okay, we reserve 3 positions, and you know that the integer, so the first digit, so it's not 0, cannot start with 0 all the time. So it's also cannot be 5, 6, 7. So let us look what A could be. So I create now a plan. I want to write at least one such a number. How would I do this? I just want to see what I have to put on the first position. 0 I cannot put. I can put 1. So let me just write, so a little bit below. I'll write, so the following. A must belong to the following set. 1, 2, okay, 3, 4, not 5, okay, not 6, not 7. Okay, so then 8, let me just write semicolon, 8 and 9, right? So I can choose either 1, put 1 or 2 or 3, how many ways? 1, 2, 3, 4, 5, 6. Okay, so 6. What is that 6? It's 10 minus those 3, and also actually not 0. Minus 1, 2, 3, 4. Minus 4, this will be 6. So I have 6 possibilities to choose the first digit. Now B could be 6, B could be 6, 5, 6, or 7. So B belongs to the set 5, 6, or 7. How many ways? 1, 2, 3. So times, okay, so 3. And finally C is not equal to 0 or 2. So therefore, so here is 3 ways. C is not 0 to 2, not 0 and 2, so therefore C could be equal to 1, so belongs to 1, 2 cannot happen, 3, 4, 5, 6, 7, 8, and 9. Okay, those 2 cannot happen, then so 10 minus 2 will be 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 possibilities. And you see that all the restrictions are homogeneous, and we multiply those, and you'll get 18 times 8 64 and 144. 144 integers. Okay, got it? So this is how you have to solve. Problem number 2. Okay, we calculate 4-digit integers. A, B, C, D. Okay, with no digits, 5, 6, 7, or 8. Okay, so how many such integers could happen? So we reserve 4 positions, call them A, B, C, D. Okay, and remember that A is not 0. So therefore, what is A? A belongs to which set? Not 0, could be 1, could be 2, could be 3, 4, 5, 6, 7, 8, we have to miss, it cannot be, and 9, yes, correct? How many? 1, 2, 3, 4, 5, 5. 5 of them, 5 different ways to choose A. Oh, I forgot. 5 or not? Yes. You see this is 1, 2, 3, 4, 5. So 5 possibilities are not allowed. 10 minus 5 will be 5. Okay. That's why this 5 I put here. Now for B, also 5, 6, 7, and 8 are not allowed. So therefore, in this case, B, okay, now B could be 0 in this case, 0, and all the others from the previous one, 1, 2, 3, 4, and 9. So therefore, it will be 6 possibilities. 10 minus 4. Okay, those we have 4. 10 minus 4 will be 6. So you put 6. Likewise for C and D. Okay, 6 and 6. So if you multiply those, it will be 5 times 6 to the power 3. Okay, and then if you calculate, it will be 1080. So this is the answer. Okay. Got it. So simple, right? Okay, next, number 3. Okay, this time I consider the number of ways, number of paths to get to E, yes, CDE, from CDA. Okay, I consider 2 different cases, 2 different ways. A. So first, these are cities A, B, C, D, and E. And there are some number of rows. From A to B, we have 6 rows. 1, 2, 3, 4, 5, 6. Okay, 6 rows. So you can start with this road and then keep going. Second one, you have 3 rows. 3 rows. So you can go, for example, like this one. You can reach C this way, or maybe that way. Okay, so different ways. Now from C to D is 5 rows. 1, 2, 3, 4, 5. 5 rows. Now we have more possibilities. Okay, go this way. And finally, for D to E, 4 rows. 4 rows. Okay, so that's it. So you pick any road from A to B, any road from this one, from B to C, and so on and so on. So for example, let me just show maybe with different color. I show you a couple of paths. Okay, so for example, like that one, this one, another one, say that one, and maybe again along this one, and then come here. So there are two different ways. So what is the total number of ways? The product. Okay, so what is that? It's this is 20, that one is 18, total 336. Okay, 360 pairs. Okay, we solved it. Okay, now let's do the following. Now we just draw a now it's circular path. The same as before. A, B, okay, so let's say C, D, and E. But now you can, and the same numbers. Okay, let me just draw just only schematically some rows. Okay, some rows here, 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 here. And this one is how many? Only 2 rows. These 2 rows, this one is 6 rows, the same as before. Okay, 2 rows, 6 rows, okay, 3 rows, 5 rows, and 4 rows. Okay. If you write that the answer here is 2 times 6, 3, 4, 5, it will be incorrect. So first you have to think, how will you drive? You can drive from A to E in 2 different ways. Either clockwise, okay, along this, let's just draw. This is A, and this is E. Either you can draw this way, okay, or you can draw that way. So 2 different ways. And they are disjoint, they are independent. If you know the number of ways to get this way, and the number of ways to get from A to E, you have to add them up together. Because they're disjoint, not multiplication. Either this or that. That's why you have to add. Here you have and. You take road here, and road here, and road here, and road here. So and corresponds to the product. This is the product rule actually. But when you have or, either this way or that way, you have to add. Okay, so let's write the following from A to E in the clockwise direction. So the same as before, 6 times 3 times 5 times 4. That's it. And we already reached 4. So the answer is 360. Now we take A and we get to E in that way, in the opposite way. So how many ways? 1 way, okay, 1 way and 2 ways. Okay, so we have only 2 ways. 2 times, okay, either this or that, 2. That's it, nothing else. So therefore total will be 362 ways, paths. Okay, by the way, so the same question, and I will ask that question. How many ways are number of paths? I don't consider this in here, but number of paths from A to D, not from E. What is the number of paths from A to D? In this case, you just interrupt yourself up here. It will be just 6 times 3 times 5, which is 30 times 3 is 90. Okay, this is in that case, from A to D. From A to D. But here it's a different from A to D. From A to D you can get, in that direction, 6, 3, and 5. 6 times 3 and 5, like here. But also you have to add, if you just go in that direction. So 6 times, not 6, now 2 and 4. 2 times 4. So you have 90 here and 8. So total number of ways is 98. Got it? You see, this is different. This is the difference. Okay. Okay, next problem is number 4 is the same we actually solved before. 8 people, pick 3 people out of 8. As president, vice president, secretary, how many ways? 8 times 7 times 6. Or just permutations. Okay, permutations of 8 and 6. Okay, you will see. I'll give it on give it in the D2L. Okay. 5 problem. 5. Okay, problem number 5 is if you choose A, B, C, 3 people at 8 desks. It will be 8 factorial or 5. Okay, I will miss that. Okay, number 6. Okay. Now, next one is important thing is if you choose, if order is important, then you choose P. Okay, please show that one if P. Okay, otherwise, if the order is not important, then you use combinations. Okay. Okay. Okay, so let's calculate how many. Okay, so this I jumped to problem number 8 because the previous problems were solved before in the previous lecture. Okay, so problem 8. Okay, in how many ways? One can choose 98 people out of 100 people. Okay, the question is how to choose 98 people. So there are 100 of them. How do you choose them? Okay, so if you choose them, okay, you can choose 98 out of 100. And so many will be the answer. But how will you choose 98? It's too complicated. It's much easier to choose 2 of them and don't consider them, right? 98 will be chosen immediately after that. So therefore, it is the same as to choose 2 people, right? At the same time, you choose 98 people. And that one we solved already, it's the number of pairs. But let's solve completely with factorials one more time to see how factorials work. Okay, so equals 100 factorial divided by 2 factorial times 98 factorial. Okay, huge numbers. But actually it's very simple. It's 100 times 99 times 98 factorial. 2 factorial is just 2. And 98 factorial is that, and if you cross, you'll get 100 times 99 divided by 2. Okay, what is, so the answer is 4950. 4,950. Okay, what is that? And this is actually, in my previous solution, is the same as to add all the numbers from 1 to 99. 1 plus 99 is 100. 99 is the number of terms, and divide by 2 because the number of pairs will be twice as less as the number of objects, the number of people. Okay. So therefore, remember. So let me just write down. N choose 2 is nothing but n times n minus 1 and divided by 2. this is generalization, okay? So 100, choose 2, and this is 100, choose 2. And this is the same as to choose 98 people. N times n minus 1, n, 100, n minus 1, and divide by 2. So this is it. Okay. Okay, number 9. Teacher chooses 3 desks. Okay, so 27 desks. Okay, choose 3 desks. And then 3 students occupied. 3 students occupied these 3 desks. Okay. Question is, in how many ways can teacher just put the students at the desk? So first, so 2 steps. Okay, so first step without order. So first choose 3 desks. It's 27, choose 3 ways. Okay, choose 3 desks. 27, choose 3. Now after that, step number 1, and this step number 2. Okay, once 3 students occupy these desks. Okay, so it will be, okay, so 3 positions. For the first student, 3 positions, for the second 2, and then 1. So 3 times 2 times 1 is 3 factorial. So therefore, in this case, answer is 27, choose 3, plus, also not plus, multiplied by 3 factorial. When you multiply by 3 factorial, okay, look here again. So it's, this one is n choose k times 3 factorial. K factorial will give this number. So that number is immediately. So therefore the answer is T 27 choose 3. Okay, 27 choose 3, it means 27 times 26 and times 25. Okay, how come? Because this one is 27 factorial over 24 factorial. How do we do this? 27, 26, 25, 24 factorial, divided by 24 factorial, cancelled out, and you get exactly this product. Okay, so if you calculate, you get, so that is important. So the final number is also important, but it's okay, that is what you have to calculate, and calculator will tell you the answer. So 17,550. Okay. Okay. Let me just. Okay. Maybe I'll tell you. Problem 11, 12, and license plates. I consider the most interesting problems number 11, 12, and 13. So, problem 11 is a problem with the star. It looks like very difficult, and it's indeed difficult if you don't make a nice, beautiful idea. So let me check. Okay, problem. Okay, number 11. In how many ways? In how many ways? can the number 100 be represented as the sum of three terms, let me just write positive terms, not zero, positive integers. Okay, positive integers. Okay, that is, for example, I take 100, it represents 49 plus 21 plus 13. Also, I can represent this 21 plus 30 plus 49, or I can represent 21 plus 49 plus 30. Okay, please tell me, are these ways of splitting into three terms, three summands, are they the same or they are different? This is the main question. So what do you think? Are they the same? Is that representation, is the splitting into three integers the same as that one or not?
Yes.
No, the sum is the same.
Sum.
But you see, they're different. Okay, 49 plus 21. So you want to say that if I exchange this number, it will be the same thing, right? But I consider, so the order of those is important. So 49, 21, and 30, I consider as different as 21, 30, and 49. Different. So it's not, so it's different, right? And I need to say that if I consider them different, I will be able to solve this problem. But if I consider them the same, the modern mathematics barely handles with that problem. It's there is a special function P. It's Euler function, special function, and that function is being investigated. Okay, these days, but it's big, so a lot of books are written about that one. But that problem, so we consider all of those different, distinct splittings. Okay, different or distinct splittings. Only in this case we can solve the problem, but that problem is very difficult. Nevertheless, solution is very easy and beautiful. Solution is as follows. I want to split 100. I do this as follows. I put 100 balls in a row. Let me just draw. Okay, so 100 balls line up, okay? And then I connect them with segments. Okay, so how to split, so if I have, for example, 49 plus 21 and 30, I put two pluses between them, right? Consider these pluses as a cut. So let me, okay, put some stick here or cut here and say cut, okay, and cut here. So if I put this cut, two cuts, I will get first summoned, right, the number of those, okay, this is first summoned, how spelling, summoned, M-O-U-N-D, or summoned, yeah. First summoned, this is second summoned, and this is the third summoned, right? So if I split this way, so for example, I count 49 here, so suppose 49, okay. Then count 21 and cut, and the remaining will be 30. Yes? So therefore, what do I do? So if I want to find splitting, I have to take two sticks, okay, two cuts, of the string here. And once I make two cuts, I have the representation. Very easy, right? So how many places in between? Number of places or strings, okay, places in between. Okay, that was the low plus minus 1. It's 100 minus 1, 99. Of them, so when I cut, I remove them. Okay, of them, okay, let me write U, remove or cut 2. And then you get 3 sums. Some months. Okay, so therefore, what is the number of representations? It is the same as the number of cuts. And what is that? So answer is, you have 99 and you choose 2. Okay, choose 2 of them. You have 99. This number 1, this number 2, 3, and that will be 99. And 2 of them I cut. How many ways? 99 choose 2, which is 99 times 98 and divide by 2. Did you calculate that before? So 2 will be 49, and so 99 times 49 is 4,851 ways. Okay, do you like it? It's very beautiful. It's a very difficult problem. If you don't know that idea, it's almost impossible to solve. But it's very simple. Now also we apply the law plus minus 1. 100 balls, or 100 marbles, and 99 spaces between them. 2 of them are removed. The number of ways to remove 2 of them is 99, choose 2. Okay, suppose I ask that question. You have the same thing. Now you want to split into 6 terms. Yeah, for example, 100 equals 70 plus 30 plus 5 plus 1. So how many? 4 of them. What's left over? Oh, it's already, no, sorry. Say 20. 90, 95, 96, 97. Okay, 1, 2, 3, 4, 5. One more. Okay, 90, 95, 96, 97, and 3. So this one split. Yeah, and by the way, so you see, the numbers could be equal here. Okay, I didn't say anything. So therefore, in this case, if I want to split into 1, 2, 3, 4, 5, 6 into 6 of them, then I have to write plus, so I have to write 5 pluses. So the answer will be, in this case, of 99 spaces, I have to take 5. So many ways, so many combinations. See, it's very simple, but the problem is very tough itself. Okay, now I show another problem, and we are almost done. With that, this is, okay, that number is, so the problem is, and you will see interesting idea. Okay, here is the question, problem 12. So I draw some rectangle. Okay, so 1, 2, 3, 4. Okay, so I have 3 here. Okay, and this I have, so in that direction I have 5, 1, 2, 3, 4, 5. I have 5. So this point A, maybe O origin, and I call it A. Okay, call it A. And I want to get the opposite vertex B of that rectangle. And the only motion allowed is are to the right and up. So for example, I go this way, then that way, and this way and that way, okay? So, or I can make it a little bit different way, so like this one, that one, this one, so that one, and here, and then out, okay? Okay, like this one. Or maybe just I go partially in here, then this way, okay, so partially that way, then this way, then come back, or maybe, yes, maybe up here, and then come that way. So how many ways go from A to B? Okay, this imagine that it's snail. Snail goes to the right and up, okay? Many times right and then up, okay? How to find that? Even, okay, look, if you just have even one square, then this case is easy. One way, and that one is another. So in this case, you have two, right? But if you cut in that way, so cut in half, you can go one way, okay, two ways, and three ways. It's three. But what if I cut like that? Now it will be more. I have one way, I have this way, I have that way, I have this way, I have this, okay, too many. And if you start, even for this particular case, it will be very tough to draw all of them and don't make a mistake. So some sneaky approach should be used. Okay, we do this as follows. We remember the idea of how we counted the number of subsets in a given set. We just coding them. We gave zeros and ones for each element. If element belongs to the set, we say 1. If doesn't belong, we say 0. So in this case, it's the same. So we call that axis, okay, we'll just write 0 if the snail goes to the right. Okay, 0 corresponds to that way. And 1 if it goes up. And each time we count the number of unit steps by 1, for example here. Okay, so for example, red one. So what is that? What is the color? Yellow. Okay, yellow path. Okay, look, we go to the right. What we have to do, what we have to write? 0, right? Now we go up, it's 1. Now we go to the right, again 0. Now we go up, 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 3 times. 1, 1, 1, 3 times. After that we go to the right, 0, and then up again. Okay, got it? So this is the path. 0, 1, 0, 1, 1, 1, 0, 1, correct? Okay, so how many positions altogether? 1, 2, 3, 4, 5, 6, 7, 8. 8 positions. What is 8? 8 is 5 plus 3. Right? 5 plus 3. So 3. Okay, I need to say the following. No matter how the snail goes from A to B, if you project down, you will have 3 steps to the right. So it will be 3 zeros. If you project to the left, okay, to the vertical position, it will be exactly 5. 1, 2, 3, 4, and then 5. And this on the top is 1, 2, and then 3. Got it? So let's write, for example, the other one, the other position. So yellow, and that one is what is red? Call it red. Red path. Okay, let's write here. So what do we do? We go up first. It will be 1, 1. Then to the right is 0. Then up again 1. Then 2 times to the right, 0, 0, and the only possibility is 1, 1. Okay, so this is the code. Got it? Okay, so for each path you have a code. Now let's look at this code. The code has length 8. It's of length 8. So we have 8 positions. And some of them are zeros and some of them are ones. How many zeros? How many? Exactly as many as the number of right motions. 3. How many up? 5. So therefore the only one we have to do is the following. Take 8 positions, 1, 2, 3, 4, 5, 6, 7, 8, and put zeros, okay, somewhere. Suppose this one, 0, 0, 0, 0, right? What does it mean? And let us draw, so, and all the others are ones. Let me just don't draw the one. So, what is that? What is this position? So 1, 1, 1, 1, then 0, 0, let me just draw in white. Okay, 1, 1, 0, okay, 1, 1, 0, 0, then 3 ones, 1, 2, 3 ones, and then to the right will be 0 again. Got it? So therefore we have a one-to-one correspondence between the codes, this is code, okay, between the codes and the paths. So therefore number of paths equals number of codes equals what we have to do. We have to put zeros at 3 places out of 8. And that will be that. That's it. H is 3. Now what is this? By the way, it is the same as H is 5, of course. If you put ones, 5 ones, it will be the same. Code will be restored uniquely. Okay, so what is the answer? 8 factorial, 3 factorial, 5 factorial, 8, 7, 6, 5 factorial divided by 6, which is 3 factorial times 5 factorial. Cancelled out, 6 cancelled out, and the answer is 56 ways. If you start drawing, then you will never get 56. Okay, got it? Okay, very beautiful idea. And by the way, it also allows us to calculate. So imagine, I will not consider this, but so imagine that how to say? Okay, some being, okay, can want to get from this corner to that corner, to the opposite corner, and this being could make either up or to the right, or up this direction and that direction, 3 directions. So how many ways to get to that one? In this case, you have unlike, okay, in the previous case, what we have, zeros and ones. Actually, you can consider marbles of 2 different colors, white and black. And this is exactly n choose k. But if you have a 3-dimensional thing, so you have marbles, so you can code with marbles of 3 different colors, say white, blue, and red. And in this case, let me just write the whole formula. So it will be, suppose I have rectangle of the size A, B, and C. Okay. So the question is, how many ways go from point A, from vertex A to point vertex B? The answer is as follows. How did we find that 8? It's 5 plus 3. In this case, it will be, okay, you go this way, that way, and that way. So it will be A plus B plus C ways. And then you choose Now you choose not only K, so you choose A, you choose B, and you choose C. So that one is called multi-combinations, okay. The answer is as follows. It will be A plus B plus C factorial divided by A factorial, B factorial, C factorial multiplied by those. And so this will be the number. Okay. Okay, maybe one more problem. Problem 13. Do you like this problem? It's very tough, but it can be done, you see, in a simple way. In two-dimensional cases on the planes, we have combinations because only two directions, 1 and 2. In three-dimensional, we have three directions. And you have to take factorial 3 times, and that will be the sum total. Likewise, in four-dimensional, so okay, so number 13. Okay, let me just write. Okay, express nine choose 5 plus 18 choose 5 plus 18 choose 6 as n choose k. Okay, solution is as follows. Solution. Okay, we use the following formula: n choose k. To get n choose k, you have to do the following: take n minus 1, take the previous one, Pascal's triangle, and add them up. If you want to find this one, you have to take this, that, and add them up. So n minus 1 and minus 1. And what you have to do? Here you have to take k minus 1, and here you have to take k. So we use this formula. This is from Pascal's triangle. So what do you see? Okay, you see n minus 1 and minus 1 is the same. Here you see 18 is the same, but 19 is not the same. So first step is the following: 18 choose 5 plus 18 choose 6 equals, okay, what do? We change n minus 1, which is 18, by n, one more, so it's 19. And right here k, which is 6. So therefore now, instead of these two sums, we write one sum on this, 19 choose 6. Okay, second one, we have 19 choose 5 plus 19 choose 6. And what do you see? You see the same row, 19, and two consecutive numbers. If you add them up, you'll get the number in the next row, 20, and you have to take 6. So therefore the answer is on 20 choose 6. So picture is as follows. So you have those ones, and you have that one, and you have to add. Okay, this is row number 19. This number 9. So 18 and 19. So when you add them up here, you got this one, and then you add them up, and you get 20 choose 6. 18 choose 5, 18 choose 6, 19 choose 5, 19 choose 6. When you up, you get 20 choose 6. Better. Okay, this is how it works. And maybe the last one, what I say is the number of places. So the number of license plates. Okay, what is better? I think we have, so what is better? Okay, let me just write here. So the last problem is 15, the number of, yeah, so it's, actually I have two more problems, but I'm not sure it's too many. Okay, maybe this one. Okay, now that problem is important. Number 14, part A. So 8-digit integers which have two fives. Okay. Number of those. Okay, you have 8 positions, so 3, 4, 5, 6, 7, 8. So 8 positions, right? And you have to, so first one is not 0, which have 2 fives. Okay, and so also, one second. And also, one second, so, and first digit also is not, 5, but it has 2 5s, so therefore two places are reserved for 5, some 2 places. Okay, maybe those, maybe the other 2. So what is the number of positions? So first of all you choose, okay, first step, you choose 2 positions out of 8. So it will be taken 8, choose 2 ways to choose 2 positions, that and that. Okay, you put them 5 and 5 and that's it. After that you stop. Now, and you know that this none of these positions number is first one. Now let's look what happens in the other position. So A is not 0, but also it's not 5. So therefore, how many possibilities we have? We have 1, 2, 3, 4, 5 not. Okay, 6, 7, 8, and 9. So 10 minus 2 will be 8 positions for the second one. Okay, this one is not 5. B is not 5. So we have 9 positions. So we have 9 positions here. This one also not 5. So again 9 positions. 10 minus 1. Okay, that we don't count. Next is not 5 again. Times 9. 9 possibilities. Not 5, it's 9. And finally it's 9. Sorry, not 5. And so we have 9. How many 9s? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So therefore the answer is 8 choose 2 times 8 and times 9. Okay. 5 times 9 to the power 5. And then we calculate it. Okay, so it's 8 times 7 divided by 2 times 8 and times 9 to the power 5. So we can cancel. This will be 28. So 28 times 8 times 9 to the 5. Okay, now after that, only after that, you take calculator and you got 13 million, 226,976. By the way, if I see that you wrote that answer correctly, that is important, or maybe even this one. This is even more important. If I see that on it, but your calculations are incorrect, I give you all points, because the idea is here. Okay, second problem B. Has no 5 at all. No digit 5. Okay, that one is easy. Okay, so A is not 0 and not 5. This is not 5, this is not 5, and so on. All of them are not 5, and we have 8 possibilities here, and 9 possibilities for other one. And so how many of them? 7. It will be 8 times 9 to the 7. And the answer is 38,263,752. So many. And finally, so that problem is simple, that is simple, but now the other, that problem is difficult on the first glance. Has at least one 5. Has at least one digit 5. So somewhere is 5, maybe 2 5s, maybe 3 5s, maybe 4, maybe all 8 5s, and also positions are different. How to find that? The problem is problem with the stars, so it's difficult. But it's difficult only if you don't have an idea how to resolve this problem. Now we have to solve this as follows. Consider all possible 8-digit numbers. And so consider this as a universal set. Okay, U is the set of all 8 numbers. 8 numbers, so 8-digit numbers. How many of them? Okay, if you write 8 positions, so in the first one A is not equal to 0, so 9 possibilities, but B, C, D, and so on, all of them are, could be any digit, from 0 to 9. So 10 possibilities, so you have 10, 10, 10, okay, so 7 times. So the total number is 9 to the power, 9 times 10 to the power 7. It's total. It's, you can write n of u, the number of elements in n of u is total. Okay, total 8 numbers. So many 8 numbers, so if you write all the numbers, it will be, okay, 9, okay, 10 to the 6, 90 million, right? 90 million. Okay, but now we consider the ones which has at least one 5. Suppose this is a set A. At least one 5, it means greater or equal than 1 digit 5, right? So that's what we want to find. Now consider the complement. What is A prime? The complement A prime, if each number here has at least one 5, each number here has no 5 at all. No 5. And no 5 we already calculated in part B. No 5. It's 8 times 9 to the 7. So therefore, what we want to find, n of A, is nothing but n of, so what is A? It's n of u minus A prime, right? So we have to subtract the number of elements in here, and you'll find the number of elements there. So the answer is, okay, where can I find? I think I erased that. So therefore, n of A, okay, you see, we just use nowadays the idea of set theory. Is equal to n of u minus n of A prime. So here is at least one 5. This one, that one is total, and that one is no 5 at all. So the answer is n of u, we found 8 times 9 to the 7th minus, and sorry. Total is 9 times 10 to the 7th. Okay, that's what we found here. And now we have to subtract 8 times 9 to the 7th. That's what we have to calculate. And if you find that, okay, you'll get, so you have to subtract from this number that number. If you subtract, you get 51,736,248. So this is the answer. So many numbers, 8-digit numbers, has at least one 5. Okay, and the number of those which do not have 5 at all is 38,263,000 and so on. So the number which contain 5, which has 5, more than the numbers that do not have 5. So we can compare and we can find the difference between this number and in the previous one is 38,263,752. So this is that number. So that difference is bigger than that number. Okay. Maybe I consider one problem. We have couple of minutes. Only one problem from number 15. Okay, so only one item, the license plates. Okay, so so this problem number 15. Okay, number of license plates. License plates. I consider only two possibilities. 3 letters. Okay. Let me just write letter, and then followed by 4 digits. Digit. So how many such license plates? And no restrictions. How many letters we have? 26. This also 26. Multiply. How many digits you have? From 0 to 9, 10. 10. So it will be 26 to the power 3 times 10 to the power 4. And then you calculate. But now, the second part. Okay, so sum 3 places are letters. Okay, remaining 4 places are digits. Okay, so here it was, we knew that the positions are on that place that we already picked from the beginning. But now the 3 places could be chosen different. So for example, this could be letter, this letter, and that letter. Okay, so many other ways. So therefore, first what we have to do, fix these 3 places. How many ways could we do this? What are altogether? It's 7, right? 7, choose 3. 7 choose 3 ways to choose 3 positions. After that, you put letters on those, multiplied by 26, 3 to the power 3, okay, like here. And after that, for the remaining one, it will be 10 to the power 4. So it's you multiply by that factor because the 3 positions are floating. And so many ways you can, so many license plates you can add. So this will be the answer. And then you have to multiply. If I calculate, I think maybe it's okay. I think I took 4 letters and 3 digits, okay. Anyway, so you can calculate using calculator, and this will be the answer. Okay, so that's it for the whole course, and I hope that if you if you learn this, you will be very good. Thank you.